Hello everyone, this is the video lecture for pre-calculus. We're going to be doing 10.5, which is parametric equations. So there's no 10.4 by the way. I don't know, I only have 10.5 and then I think I got 10.6 after all this. This is actually a pretty short section, and I feel like the last two are, well, they're a little bit nicer than some of the ones we've done previously. Parametric, it's actually Greek. Para means concerning or about, and then you got metric means numbers and measurements and stuff like that. So concerning measurements, you totally understand what's going on now, right? No, um, it's that x and y are functions. They're functions in terms of t. Now, so that's the kind of trick right here. So in a way, I have x in terms of t is equal to blah, 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 and y in terms of t is equal to blah, 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 blah. Let me give you, I'm just going to jump into the first question actually as a good example for this. Let's see, I got x of t is equal to t plus 10. I got y of t is equal to t squared. And then they say go from -2 to 2 with your t. Okay. You can actually graph this on Desmos. What it looks like is on Desmos, like I'm just going to be straight with you. Desmos graphing, what do? You type it in parentheses as t plus 10 comma t squared close parentheses, and it'll say, do you want a slider? And there'll be like a slider thing down here. And you're going to choose the t -10 to 10 option, I guess. Now, it says -2 to 2, but it doesn't really matter. The idea is that you want to just graph this thing and see what's going on. So you can change it to a 2 if you want, but it's not going to help you here. And so when I graph this thing, I see this. Whoosh. Whoosh. Okay, I see that. But that is not good. Not. What we need to see is this instead. Whoosh, whoosh. So, Desmos is not graphing these little arrow things for you, but we need to know the direction. Okay, direction is important. So I'm going to put a star on that one, okay? So the direction is important because time goes from negative to positive, and so where's this graph going? It's going this way. It's going this way, that way. Okay, so that's the graph. It's not just about what picture it looks like. It's about the direction where it's going. Okay, cool. So how do I know the direction from Desmos? Let's just say I was wondering about that. Well, you got slider things here. Couldn't you like slide it back and forth? I mean, it looks like a big dot thing, and it's on a slider, and you just go whoosh, 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 whoosh with it, and you can see like where it's going. You could change your numbers, and so you can say, well, let's go to 0. So -10 to 0, it would just go like brump. And then you're like, okay, cool. Now let's go from 0 to +10, and it'll go brump. And so like you can see that it's this side, then that side, so that's that motion going on. But ultimately, because, let me remind you, this is MATH 2412. There's a 2 right there, which means you're upper level. And so if you look right here at your x value, it's positive t. It's like a positive slope. And so it's going to go positively. The more t, the more x. It's like take t and make it a 10. You're going to have more x. Take t and plug more t in, you're going to get more x. More t makes more x. Okay? So that means it goes that way. There we go. Now you're advanced. So you will be using this extensively in Calculus 3. This is like whole chapters are devoted to this stuff here, okay? Multiple chapters. So I know that not every one of you is going to Cal 3, but for those of you that are, this is a super important topic, and you will be using it again, and again, and again. So they say graph this thing, and I'm just going to use Desmos again. It starts at 1, and it goes like this here. Again, if you look right here, this is positive, so the more t, the more x. Okay, so it's definitely going that way. It's starting at 1 because the 1 right there, the square root comes from that format. But honestly, between you and me, these are like the easy ones. And I'm using Desmos graphing just because I can. At this point of the game, it's not bad to do. Since we can use it on our exams and stuff like that. And so if it were me and I was sitting there on an exam saying, well, what does this graph look like? Well, besides the fact that I already know all these answers, because I do Calculus 3, let's say that I didn't know them, I would use Desmos graphing to at least help out. So what is this thing going to be? I'm going to just tell you it's a circle. So this is actually a really cool design. Because x is cosine, which is very typical, that's normal, right? Cosine, you think that's the x value. That's correct. And so you're going to start here at 0. That's 0 right there. And you're going to go around and around until you get to 2 pi, like they said. Done. Now, I'm going to redraw my circle because that really didn't look good. Oh, come on. Woo, close enough. Okay, so my circle goes out to 2 pi. So how far out is this? Well, I don't know. Probably the radius is 4. Do you see that? R cosine theta, R sine theta. I mean, this is like way clear. Yeah, we've already done this before. So this is a 4. This is a 4. Well, it's a negative 4. And this is a negative 4. You get the idea. This is super easy stuff. Again, direction is super important, counterclockwise for circles. So make sure you see that. It's going around that way. Okay, next one. I've got x is equal to t, and then y is equal to 11t, and they say go from negative infinity to positive infinity. Okay, find the rectangular equation. Eliminate the perimeter. Eliminate. Oh, whoa. I didn't spell it right. Eliminate the parameter. They're basically saying get rid of t and go back to rectangular format. Okay, now this is kind of rectangular in a way still, so I don't want to go too far down that road. Eliminate the parameter. This is super easy. This is the easiest one yet. If x equals t, and therefore I could say that t is equal to x, so I got y is equal to 11x, and ta-da, we're done. Like, it was just that easy. Graph it. You can see it's a line that goes up like this. There's your line. But direction's important. The more x, the more t. Notice that's a positive. And so it's going to go in the positive x direction as you continue to get more t in there. I think that was almost too easy, so we need to do something harder, don't we? X is equal to 6t plus 3. Y is equal to 36t squared. And we're going from negative infinity to positive infinity. Eliminate the parameter. Same thing. So this one's not as easy, but I still think I could solve for x here, or t. I could solve for t, and then I plug it in. It's kind of like systems of equations where you solve for one, plug it in, solve for the other, which this is easy stuff then. So yeah, I know we got a fraction, but who cares? You're advanced math now, right? And then they're going to square it. Oh no. Well, like, you're done. We just need to, simplify a little bit here. So that 36 is kind of interesting. I'm going to distribute the square to the top and bottom on purpose so that I can cancel. So I'm not going to try to do individually on the inside. I'm just going to try to cancel and make it look pretty. And indeed, my math lab is happy with that. And so what shape is this? It's actually a parabola. So 1, 2, 3, and there you go. The problem is again, direction. Go back to your x. Notice that it's a positive. The more t, the more x. So I'm definitely going this way, basically. So I'm going to follow the path. There you go. Parabola. Okay, I got actually 2 more problems and we're done. Now this one here is like super big. So 10, 5, 33. I've got x is equal to 2 plus 3 sine of t. And I've got y is equal to negative 2 plus 2. I messed up. Hold on. I'd rather just go back and redo it. This is not a sine, that's a cosine. I'm sorry. Well, it's a good thing I saw that now, because that would have made things a lot more difficult. Okay, there we go. And they're wanting to go from 0 to pi. Eliminate the parameter. Now, I have a whole page on how to do this, and at the very bottom I wrote easy. So there is an easy way to do this for sure. If you recognize what's going on, you can just get the answer. You want me to do the easy way first or the hard way? I know some of y'all are like, hard way, hard way. You're not? You're saying the easy way? Oh, okay, I guess that's fine. So notice that we have x equals 2 and y equals negative 2. So my center is actually going to be this. Okay, so that's kind of a start. Notice that x is a cosine and y is a sine. So that's a circle again. We've already seen this. But it's not a circle necessarily now because we've got a 3 and a 2. Okay, so notice that it was going to be a circle, right? It was going to be a circle centered at whatever. But because there's a different radius here, this radius is 3. So from here I go 1, 2, 3, 1, 2, 3. But for my y's, I'm only going 2. So it looks more like this. What shape is that? That is an ellipse. Exactly. So it's an ellipse centered here. And indeed, the bigger one is the major. And it's an x major because it's the bigger one. And this is a y minor because it's the smaller one. They're both positive, so that didn't worry me. And so my answer is going to be x minus 2 from the center, right? My major is a 3. And then I got y plus 2 from the center. And then my minor is a 2. And then that's it. You're done. So, of course, simplify the bottom for my math lab. But there you go, an ellipse. Yay. So recognition of this stuff is super important as you move on to Calculus 3. This is just a given. I'm just going to say, what shape is this? And you're going to say ellipse. And just walk away. Next question. So let's do it the long way because I feel like I got to do something proper as a math teacher. No? All right, well, you can skip ahead then. I'm imagining you skipping ahead right now. You're just like, okay, fast forward. Let's be done with this problem. I think I got everything right. So I want to solve for t. And so I'm going to move this over and divide by the 3. So x minus 2 all over 3 is equal to cosine of t. That's happy days, but not really, honestly. So t is equal to the arc cosine of x minus 2 over 3. So what's going on is that when I take this, I need to take this t and plug it in right there. And so we get negative 2 plus 2 sine of the arc cosine of x minus 2 over 3. Have you skipped ahead yet? Because you don't care anymore? I get you. When we do this here, how do I solve? How do I simplify? You actually need to draw a triangle. There's your theta. Well, kind of. This is your theta. This is your A. So let's do A, your angle A. Now, in order for this to be A, I have cosine was equal to this stuff here. So that's my adjacent, and this is my hypotenuse. So to find my opposite, I need to do 3 squared minus x minus 2 all squared. Now, they're wanting the sine of that, the sine of this guy. So, like, you can see that what I'm doing now is the sine. So negative 2 plus 2 times the sine is opposite over hypotenuse. So we got square root of 9 minus x minus 2 all squared, then divided by the 3. And there you go. You did it. Yay! Isn't that the same thing? Yeah. No. It's not the same. Look, that's pretty. What's that hideous thing? I don't know. So move the y over, and then I'm going to divide by the 2. Actually, I think Yeah, let's do that. So I'm going to move the y over. I'm going to divide by the 2. I'm going to multiply by 3. Yeah, nah, let's not move that 2. Let's not do that. So I've got 2/3 square root of this junk. And I need to get rid of the square root. And so what I'm going to do is square both sides. And the reason why I was going to put the 2/3 over here is because it just looks a little bit better. But I know you can do this. So the square goes to every component. So that's actually 4/9 right now. And the square root and the square cancel. Okay. Now I'm going to move that 9 over. No, I'm not. I'm actually going to move the 4 over. I know this is really weird, but hang with me for a second. Okay, there we go. I want to keep the 9 here because that's part of the ellipse style, right? You got your squares in the bottom. Distribute your denominator, so then both of these get that divide by 9. So there's nothing that changes over here. On this side, we got 1, and then we got a x minus 2 squared over 9. Then, because it's negative, I should try to make it positive, so move it to the other side. There's my x component with the 9. This is positive the whole time. It's a 4, and there's equal to 1. That 1's right there. There you go, ellipse. Wow. Wouldn't it have been better just to, I don't know, look at it? Yeah. So, last question, and this is actually pretty fast question. I think I used Desmos for it. So I got x is equal to v naught cosine of theta times t, and then I have a y is equal to h plus v naught sine theta times t minus 16t squared. They say that theta is 65 degrees, and then they say v naught is 150 feet per second. It's a projectile problem, and I'm just going to show you the basics of what we're talking about. So they're wanting to send a projectile out, but we start here at an angle of 65 degrees, and the initial velocity is 150 feet per second. And so obviously gravity's going to take over. It's not just going to keep going straight up like in space, and then eventually, boom. So it's a projectile problem. So they're going to ask for max height, and that's going to be right up here. So how tall does it get? They're going to look for the range, and the range is how long it was. So like basically what x value do you have way out here? And then there's other things that they're asking for, but they all kind of exist from the graph. Well, guess what you can do? Desmos. Yep, Desmos graphing. You put this in, of course, and you put this in. You know, you're plugging in your values and stuff. But what is h? Did they not say what h was? I think h might be a 0, or I don't know what that number is. They'll have to give it to you. They have to. So it's either a 0 or some kind of number. But Desmos will give you what the max is. You just like click on it, boop, and it'll give you the point. It'll tell you when it's intersecting the x-axis. So, like, all of this stuff is like not hard. They want decimals also. So Desmos is like really nice because they want decimals. Decimals. They want decimals, guys. It's okay. Just use Desmos, and that's it. I wasn't even gonna do that problem because it's just Desmos. Thank you very much. Have a great day.